So now I have connected the load 4K7. We are supposed to observe the effect. Okay. Previously, see, I have just showing. This is previous is 1K. Okay. Now I am connecting a 4K7. So after connecting a 4K7, after connecting a 4K7, see on the transmitter side we are having a 2.08 and on the channel 2 we are getting 144 millivolt. So we are getting some millivolt amplitude. Now again we are interested in measuring a propagation delay for this signal. So again measuring a propagation delay for the signal. I am using a cursor again. I'll use a cursor again. I'll adjust this point. I'll use a cursor again, which is a cursor point, time cursor. First cursor is at that position only. Now the cursor 2, I need to measure. So now this is using a 4K7 resistor. I am getting a 640 microsecond propagation delay to transmit a pulse. So this is a propagation delay that is going to be introduced. Okay. Now after completing this, now I am connecting the op-amp output. Op-amp output for connected to the 4K7 only. So 4K7, this is the op-amp output. So we can (4K7) op-amp output is measured. So we are going to get a channel 1 is a 2 volts and channel 2 amplified with a 1.84 volts with 4K7 input. Now I am connecting R1 again and measuring it, acquiring the data and measuring it. So I am getting channel 2 output as 460, which is amplified output with 1K connected. Now this is a 1K connected. See, this still noise is there, even if it is amplified, some noise is there. Okay. Now I am connecting. Now I am connecting on the output side. On the output side and the channel 1, I am going to connect again to the pattern. So channel 1 is connected to the pattern. See, whatever the input we have transmitted, that we are going to get on the output side with the amplification. So channel 1 3.34 millivolts and 5.2 volts on the output side. On the same way we can draw for (1K) also we are going to receive the same output. Okay. This is our first part where you have to draw the clock signal. You have to draw the pattern, that is the input to a transmitter, output of a transmitter on the receiver side with waveform with R1, waveform with R2, op-amp output with R1, op-amp output with R2, and this is the final output. This is the first part. While doing the experiment, we have measured the propagation delay for each and every point. Now we are in interest of the measuring the R pattern. R pattern where the channel 1 has to be connected to the clock signal. Channel 1 has to be connected to the clock signal and channel 2 is connected to the op-amp output. After connecting channel 1 and channel 2 on the op-amp output, what is our interest? We are in interest of the R pattern. So wherever the trigger source is there, that channel 1, you are supposed to set a channel 1 as a trigger source. Then only you are able to measure the R pattern or observe the R pattern in the channel 1. Now see, we can see that this is R pattern where I have connected the 1 kilo ohms resistor. Now I need to find out the frequency limit. So frequency limit, so this clock signal can be changed where this is a wide eye open. This frequency has to be changed till this frequency point eye is closed. How you will understand the eye is closed? So as I change the frequency limit, see your waveform is going to change. These 2 points will come together. So these 2 points will come together. Now I am changing. At one point this eye will be closed. Continuously I am measuring it. So this closing point I am getting as 4.01 kilohertz. Now this waveform we can see in the YT mode. If I change to the Exp4 mode, see this is a eye closed indicate. If I change this is a eye open. Now at the point this is wide eye open previously. Now if I change it, it will start 10 inserting in this side, and if I change on the YT mode, I can see that my eye is closed. I can see that my eye is closed, and I have told you the frequency, which is now this is exactly 4.016 kilohertz. So this is a 4.16 kilohertz for R1. For R1, now I am changing the load to 4K7. Now if I am changing the load to 4K7, I can see the eye pattern again. Now this is a clock signal. Now again I need to find out the frequency limit for this also. So 4K7, in the frequency response we have studied, as load increases, bandwidth is going to be decreased. So this is now, if I low frequency, this is wide eye open. Now if I am changing, at one point these 2 points will come together, and if I am not able to observe this, I can use a YT mode. I can use the Exp4 mode and I can change it. Okay. Now this is 1.38 kilohertz. You can see in display of Exp4 mode also. See, this is it started eye closing. Previously this is eye closing point. Previously this is wide eye open. Now at this point this is eye is going to be closed at one. See, you can make out this point. Eye is closed. Acquire and measure this. So we can see the channel 1 frequency as 1.55 kilohertz. So this is a frequency limit for your 4K7 load. This is how the eye pattern has to be observed. This is wide eye open with 4K7, where you have to connect the clock signal to channel 1 and CRO trigger source also to channel 1. Connect op-amp output to channel 2. You will observe the eye pattern, and this is the frequency limit of your transmission, and from that you can calculate data rate.